glad to see you here. This is my first presentation here at Positive Hug Day, so PhD. I'm very glad that despite the beautiful weather we have outside, you chose to be inside and listen to a little bit boring presentations on those 5 acute problems of your serverless solution. So my name is Anton Chonousov. I'm developer at Yandex Cloud, developer advocate at Yandex Cloud, and please raise your hand if you listen to podcasts. Some amount, maybe 20-25% of the audience. Well, the thing is that podcasts played a big role for me in this topic. A few years ago, one of the guests in my podcast told me that there is a thing called serverless, and I was like, what is that? What is exactly serverless? And I actually went and saw what serverless were at the time, and I really liked the topic. I really liked it. And I thought that because of that meeting, because of that podcast, I was able to work in Yandex Cloud, and I've been working there for 4 years, talking about serverless solution, obviously beside the other work I do there at Yandex. Clearly, I am in different podcasts. For example, this podcast you can see online where we analyze potential mistakes. So I'm a developer advocate, I work at Yandex Cloud, and if for some reason you have to leave immediately, I want you to have this takeaway. When you look at a cloud, any cloud, whatever the cloud is, you have to imagine like this picture, this pile of Lego cubes. It was just put there. But when you have a single set of Lego, you either have it ready or you either have it in a box. But when you have a child and they have 5, 10, 6, 78 sets of Lego, it doesn't really matter. They end up in a single box and they're all mixed up. And the more services provided by the cloud, the more it resembles this pile of Lego. And you can say, wow, it has everything, or maybe it has nothing. I have no idea. Nothing fits my problem. I need a new set. But actually, basically, in any developed cloud, you are able to create your own spaceship from what you have available. You can create your own solution. Clearly, that there are some better cubes and cubes with lower quality. But this solution, it depends not what kind of pieces are available. Most of the cases, the pieces are pretty good with the correct interfaces. But this ship, the spaceship, depends on you. It depends on how you put those pieces together, how you create systems, and how you create interfaces and join those interfaces together. I hope that you, if there's a single takeaway, this will be the main idea of the presentation. So now if we go a little bit to serverless and going through all this hype, it started with the first successful implementation in 2014 in Amazon. A big company. Obviously, it was not the first one, it was not the pioneer. If we dig deeper, there were very similar developments that happened before, but it was the first success in terms of commercial. It was the first commercial success. And then everybody decided to have similar clouds. So what was Fashion as a Service, FaaS? Please raise your hand if you write any scripts using Python, any other languages. Okay, so now you understand, basically the audience. Now you understand that there is a typical Python script where you need to put something from X to Y. It's a very simple script, 50, 60 lines with some libraries. You just run the script, it worked, it died, and that's all. But just imagine, a function in serverless is basically a Python script. You create a snippet of code, you have a set of languages, and then you send it to the platform in the text format, and the platform will package it itself and run when there is a request by the user. You are not working with the server, you're not working with any of this. You just send the snippet of a code and it's run there. Users get a lot of joy, and obviously there are some trade-offs. If we, once again, dig a little bit deeper, sure, there are some good practices, bad practices, great books, more or less good books. Kaiser, Mike Roberts, I think these are the more interesting ones. You can see them on the QR codes. And this year, in the beginning of 2024, there was a book from Luke Hedger and Shane Bristles. They published a book on serverless development on AWS and Amazon. And it's a very good book. It seems like it's about Amazon. But obviously, Amazon is very far from Russia. Still, if we can throw away the Amazon part, then the rest of the philosophy, the rest of the book, what kind of patterns, what kind of methodology, why and how everything is interconnected, it has a very good systematic approach. I think this is the best serverless book on the way to approach the development of application, not about the services per se, but about the methodology, how to understand how it works. You can just read the book, use it as a tabletop book. It was published just a few months ago. I read it really well and I really enjoyed the book. So I recommend it highly. Still, when we work with serverless as an approach, we have to take a look at what this approach provides. As I said, some kind of abstraction. You create a script, but it has to be run somewhere. And we don't understand that you have to have some kind of virtual machine, right? But you do not have access to this virtual machine. Serverless takes away this access. And it tells you, okay, provide me the code. You concentrate on the code. But we, as a platform, will create this quote-unquote virtual machine. We will give the user request. We will work through the code you sent us, and then we'll turn it off. And based on this basic idea, all those serverless services started. Three basic things. Abstraction, we have a code, we run the code. Now we have scaling. If your code can be run and it does not require any additional dependencies, it means that you can automatically scale it. You can run the second, 13, 30-second virtual machine, they will work and they will die.
из этого выросла еще третья концепция, так как у тебя, как у
провайдера, the next concept, you as a provider has a very big cluster where machines work and die, you can give a very good economic, cost-effective request that millions of requests, millions of function calls would cost just a few rubles. And it seems like all that was created for a chaotic load. How does it look like? Just imagine a typical application. I really like an example of about weights. You use weights in the morning, it measured how much you weigh, and then you have maybe smart weighs, and it sends this information to your desktop, maybe to your watches. Imagine that we are in Moscow, 7 a.m., millions of ladies try to measure their weights, and this is the peak load, basically a peak, but nothing happens during the day. Nobody cares about weights. Well, maybe somebody woke up at 11 a.m. and they measured their weights. And you can see that the load has many multiple peaks. And if we use the classical approach, we would have to work really well for this peak load. We as engineers do understand that ladies would weigh themselves in the evening. It will be lower than in the morning because of the psychology, but it will be the second peak. But in the middle, we'll have nothing. How much hardware will be idle during those two peaks? Nothing happens. I'm just waiting. But this does not happen in serverless. And the reason is that we run multiple virtual machines. They worked, they died, and we don't pay anything else if they don't work to the platform. Or just deploying our functions, and that's really good. If we move a little bit further, there should be some kind of set of services that allow to
Понятно, не только должны быть функции, должны быть какие-то очереди,
implement your
должны быть
solution.
базы данных.
Sure, there should be some
И в
queries,
целом,
some
если мы
databases, some
посмотрим на
lines,
Yandex
some
Cloud, то
codes.
у
And
нас
if we take a
давно
look
этот
at
набор
Yandex
уже
Cloud
реализован. И
solutions,
появляются
we
новые
already have this
serverless-сервисы.
set of
Если
different
смотреть
solutions,
на
and we
других
have new
игроков на
serverless
рынке, я тут
solutions.
упоминал
If
уже
we take a look at
у
other
них
players, I
там,
already mentioned
если
Amazon,
посмотреть
AWS,
последний реинвент,
you can
там
take a look
практически
at
в
their
каждом
latest reinvent,
выступлении
and
есть,
basically
вот
in
мы
each
добавили
presentations
serverless
they
компоненту,
have
вот мы добавили
we have
serverless
a new
обработку.
serverless
То есть, в общем,
component,
этот
we
тренд,
have a
который мы
serverless
можем
processing. So
бесконечно
this is the
видеть в
trend which
2014
will
года
going on and
развивается.
on, and
Он
at least in
уже, там хайп прошел
2024.
давно, там уже
The hype
продуктовая такая
already died
классическая
out.
разработка.
Now it's
И
just a
понятно,
classical
что
product
вот эти вот
design.
классические истории, что
And
вы
it's clear
что-то
that
вы
those
платите за то,
classical
что вы
stories
пользуетесь,
where
и не
you
платите за то,
pay
что
for
не
something
используете,
which you
это
use and
какие-то
don't pay for
свойства, которые
something you
присущи
don't use,
многим
these
сервисам
are
в
some
облаке.
properties which
И
are
в
part,
целом
integral
это
part of cloud
правда.
services.
Есть
And
очень
it's, in
большое
general,
количество
it's
сервисов, которые
true.
сопутствуют.
There are
Если
many
вы будете
services
работать в облаке,
which
а облака с нами надолго, то
follow this, and
очевидно,
if you
что
work with
будете
clouds,
работать
and
с
we
ними
will
в
work
том
with
или ином
clouds,
смысле.
it is
Например,
obvious that
практически
you
все из
will be
вас будут
working with
работать
them
с
maybe during the
PMS,
peak
то есть там, где
loads.
хранятся
Probably
ключи,
everyone would work with
безопасненько,
key
аккуратненько,
MS,
вы
where
все
you
с
can
этим работаете.
store
Она
your
обладает точно
keys,
такими же свойствами serverless.
and it has the same property, just
Используете,
it's
не
basically
используете,
serverless.
платите только за
Whether you use
использование,
it or
оно
don't
там
use,
без
you
вас
pay only when you use it,
тратится. В общем, как-то
and
там
it doesn't
такая
take your
составляющая.
money when you don't use it.
И
This kind of approach.
если мы в целом посмотрим на
In general, if we take a
serverless,
look at the
то
serverless
есть
solutions,
такой момент.
then
В
here's the
целом
point.
сейчас принят подход, когда мы
Currently,
строим систему. С одной
the
стороны, у нас
approach is
есть
as
наработанные
follows.
какие-то разработанные
On
приложения,
the one
а с
hand,
другой
we have
стороны
some
мы рядышком
applications,
пристраиваем
and
serverless
on the other
сервис.
hand, we
То есть,
try to use serverless
как я
solutions.
уже и сказал, мы по чуть-чуть где-то внедряем под конкретные
Bit by
задачи,
bit,
которые
step by
подходят
step,
под
we
наш объем
implement
трафика,
specific
вот эту пилообразную
tasks
нагрузку, где подходит
which
под вот этот вот некоторую хаотичную
fit
составляющую,
our
и мы
peak
постепенно
loads, maybe in the
с ней работаем.
morning,
И если
maybe in the
мы
evening,
начнем
very
смотреть на эту схему, то
uneven
мы,
peak
с одной стороны,
load.
увидим
And if we take a look at
какие-то
this
внешние
scheme, if we
source,
take a look at this
ресурсы.
design, we will
Что это
have
может быть?
different resources.
Казалось бы, да, вот
So
у вас
what could
есть
this
входящий
be?
запрос, который
It seems
приходит в
like you
систему,
have an
обрабатывается каким-то контейнером,
internal
какой-то очередью.
access, internal
Есть
input.
отдельная
It
сложная
is
обработка, например, в Kubernetes,
processed.
который у вас под
You
параметром
have a
постоянно
very
куплен. Вы
complex
такую сложную систему строите. А что
processing in
является
Kubernetes,
источниками
but
запросов?
what's the
Ну и,
source
конечно же,
of
источниками запросов
the
может быть практически
requests?
все, что
And
угодно.
obviously,
И
anything can
как,
be
как
requests.
часто, вот у вас у всех, наверное, есть Telegram, да? У кого есть
Probably
Telegram?
everybody uses Telegram.
Да, у
Please,
всех
by show
100%
of hands.
практически есть Telegram.
100%. Practically
Отлично.
100% of the audience
Классический пример.
uses
Сообщение,
Telegram.
которое
So
приходит,
here's the classical
обрабатывается,
example.
всякие Telegram-боты.
You have an incoming
Представляете,
message,
у кого
it's
есть
processed by
свои
Telegram bots,
маленькие, ну здесь же
and who
хакеры
has,
собрались, да,
well,
ребята,
we
которые
have hackers here in the
более
audience,
любят какие-то проекты поделать.
people who want to have these pet projects. Anybody created a Telegram bot?
Ну, процентов 70, наверное.
About
Отлично.
70%.
Вот смотрите,
Great.
Telegram-бот — это классическая история.
Telegram
Вам
bot is
приходит
a
запрос
very
от
classic
Telegram,
example. You have
внешний
a
источник.
request from Telegram.
Он
It's an
проходит
outer
через некоторый
source.
API gateway,
It goes
вы дальше
through
его
some
обрабатываете и дальше
API
отправляете
gateway,
ответ
you
пользователю.
process it, and then you send
Что-то у вас там
the
случается внутри.
answer
По
to
факту
the
что?
user.
Приняли
Something
запрос,
happens inside,
как-то
you
обработали,
just
отправили ответ.
took in the request, you processed it,
И
and then you send the
где я
answer.
такое видел? Какие-то
And
события, которые
it's
случаются
very
снаружи, мы
similar.
тут всех
Something that
обрабатываем, они
happens on the
приходят.
outside, we
И
process
эта
them, and they
история,
go
в общем,
our
мне
way.
напоминает
And this is very, very similar, at least to me.
историю, связанную с
It's very similar to
запросами. Запросы,
requests.
связанные с
Requests connected
чем-то. Я
with
решил поспрашивать
something.
Яндекс.GPT,
And I decided
с
to
чем
ask
это может быть связано?
Yandex GPT what this could be
Какие-нибудь
connected
системы
with.
такую же
Maybe
историю
some kind of systems
и такими
had
же компонентами обладают, так же
these similar
взаимодействуют, так же
components,
работают.
maybe
И очень
they
быстро
interact the same way
ну,
and
я, кстати,
very
очень
fast.
хулиганить, поэтому я
Actually
огромное
wanted
количество
to
вопросов задал
play a little bit
Яндекс.GPT,
around.
набрал
That's why I
более-менее
asked
приличные
many
ответы
questions and I
и
selected
решил
the
их
more
проанализировать.
civil ones, let's say, and I
Оказалось,
decided to analyze the answers.
очень
It turns
быстро
out that very
Яндекс.GPT
fast,
связал
Yandex
serverless
GPT
вообще всю
connected
тему
serverless topic as a whole in general with
микросервисной архитектурой
microservice
в парадигме
architecture,
event-driven development.
especially for practical
Моментально
event-driven
практически.
microservice architecture, basically
Система
instantly.
построена на вызовах,
Because the
на
whole
запросах,
system
которые
is
приходят от
based on the
пользователя, которые
requests
генерируются внутри
which
системы. И я такой думаю,
arrive from
блин, а
users,
это ж
they're
правда.
generated inside the system.
Почему у
And
меня в
I
голове
thought,
это
wow,
никогда не
that's true.
стыковалось?
Why I never
Я
had
рекомендую
this
эту
kind of
книжку, она
connection in my
неплохая.
head.
В принципе,
I
есть большое
highly recommend this
количество
book.
книг по
It's
этой теме, но она
pretty
в
well.
целом неплохая. я
It's
решил,
pretty good book.
уже нейронные сети связали эти два
And
понятия,
I decided that if neural networks connected those two definitions, maybe I should dig a little bit.
нейронные сети немножечко,
Everybody probably
они иногда
heard that
галлюцинируют.
neural networks have
Как будто бы их надо
hallucinations.
проверять, что вот они
Like you need to
правду
double
вам
check
сказали.
if they actually told you the truth. You ask them a question and you have to
Ну, это же недостаточно.
maybe
Надо
double
еще
check.
каких-то источников.
I took the
Я решил,
book
ну, надо свеженького
and I
что-нибудь.
said, well, this is not enough. I need more
Вот
sources.
вообще просто вот ну, так
By raise of hand, who hates reading books?
Вот лучше видос посмотреть. Кто лучше видос
It's better
посмотреть?
to watch a video.
Давайте
Raise your hand.
по-честному там.
No,
Видос
be honest, be
посмотреть.
honest.
Всё равно,
It's better and easier to
иногда там
watch a video.
включил, там чаёк
Sometimes you can
попил,
have it in
сидишь,
the
оно там
background, you
что-то.
can eat, you
Я
can
собрал
drink, you can do
какое-то
something else and listen to the video.
последних
And I
самых интересных
collected
выступлений на
a
тему
number of
event-driven
interesting presentations
архитектуры.
on
Можете приходить смотреть.
event-driven
Они реально
architecture. You can
классные, из
actually
разных
go there
источников.
and watch
Они
this
посвящены
from different sources. They are
соответственно,
dedicated to
истории, генерации, паттернам.
story generation, patterns,
Те ответы, которые я получал от
and all the answers I got from Yandex
новыми
GPT.
докладами, я сравнивал и пытался
I was
понять,
able to
насколько там
compare it
точно
to new
ведется и где
presentations
момент.
which I found here
В
and
целом,
compare
по
and
теме,
contrast
мне
them,
кажется,
see
это
if they
достаточно
actually
удобный такой гайд. Можно
relevant or
взять
not.
за
And I
10
think
всё
it's pretty good
посмотреть
guide.
и
You
получить
can watch all of them in
массу
one
удовольствия.
evening
Они
and you'll
хорошо
get a lot of pleasure.
сделаны. К
First of all,
сожалению,
they are
большинство
very
из них
well
на
made,
английском языке.
or maybe
Но я
all of
думаю,
them
в этой аудитории
use
нет ни у
English,
кого
but I
проблем с этим.
believe
К тому же
everybody
в
can
Яндекс.Браузере
understand at
появился
least English. And Yandex Browser
Вот.
has a single button translation
Вот,
option
значит,
now.
я спросил Яндекс.GPT, а вот что такое
Яндекс
event-driven
GPT,
архитектура, раз ты уж меня связала
I
сервис
asked Yandex GPT
выдал мне
about
определение,
event-driven
там, правда,
architecture.
еще
So it gave
всего
me
я
the
употребил
definition.
маленечко.
It had
Я
a
говорю,
lot of different
а что самое
unnecessary
важное?
things. And I was
Давай
like,
нет, суммаризируй,
what
еще,
was
еще,
the most
дожми
important
это,
part?
прям
And I
совсем,
said
чтобы выжимка была.
to Yandex,
Он раз мне
summarize
говорит,
it.
вот
And
это
it
самое
gave
важное.
me this.
Это
It's an
подход, в
approach
котором
where components interact with each other through exchanging
Ну, у нас же
events.
тоже serverless, вот пришло событие,
But
вот
serverless is the same.
мы
You
отработали,
have
умерли,
an
а
event,
ответ отправили
you run the
пользователю.
function, it worked, and then it died off, and we
Да, я так
send
думаю, ну, может быть, я
the
событие
answer
как-то
to the
неправильно
user.
понимаю,
So
скажу
basically,
еще,
this is an event. And I
один
thought,
такое событие,
well,
да.
maybe I have a wrong
Ну, и
understanding of
оказалось,
an
что я
event.
правильно
And I
понимаю,
decided
что
to
это
ask
значимое изменение
what
состояния
exactly
системы или
an
ее
event is. An
окружения.
event is
То есть,
a
здесь
meaningful
появилось
change
еще
of a system or its
внутрисистемное.
environment. And now we
Внутрисистемные события, и
have an
это
additional.
все, что
It
внутри
should happen inside the
serverless экосистемы
system.
происходит.
And anything
Это
happens inside the
взаимодействие вызвано
serverless
триггерами,
ecosystem.
различными
This is
запросами,
something that
таймерами,
happens by
это
triggers,
события в
timers.
очередях, которые происходят. То
These
есть
are
события от
queries,
внутренних источников
events,
внутри
something that
системы,
happens
они тоже
inside the
считаются событиями.
system.
Ну и по факту
And all
они
that are
ими
considered,
являются. Вот.
all that are considered events.
Собственно говоря, пока все
So
бьется. Я думаю, ладно, хорошо, а что же является
everything
обработчиком?
checks out.
Ну, это же event-driven
So,
архитектура.
What would
Определение
be the processor
классическое
of an
образовательский
event?
язык
And the
только,
classical approach,
и Яндекс
if we
его прям
consider
сразу
event
говорит,
handlers, and Yandex GPT
это
gives me
функция.
this
Блин, это
definition.
функция.
It's just a function.
Блин, да,
Well,
действительно функция.
really,
Мы
it's a
реагируем на
function,
события. И по
and
факту
we react to different
платформа,
events.
любая
Basically,
сервис-платформа
a platform,
принимает
any
пользовательский
serverless platform,
запрос,
takes in user requests.
внутри берет ваш код, который вы где-то написали, да, и положили в
It
платформу.
takes your code,
К
which
этому
you wrote,
запросу создает
then
маленькую
it
виртуальную машину,
creates a small
специальную
virtual
рабочую
machine,
куда
a
подтыкает
special
память,
dedicated
и ваш
working area.
и туда передает,
It
соответственно,
allocates memory
вызов
and your
обрабатывается.
code.
После этого виртуальная
It
машина умирает.
processes the request, and after that,
То есть, собственно
the virtual
говоря,
machine
это вот
dies off.
функция, которая сама
So
по
this
себе
is the
в классическом
function
виде. То есть, если
which in
мы
its
хотим
classical
реализовать
approach
event-driven архитектуру,
looks
то по
like it
факту
is.
serverless под
If
это
we want to
подходит
work with
максимально хорошо.
event-driven architecture, then serverless solution is very well made, is a very good
Упала,
solution for this.
двигаемся
You
дальше.
run with event handler, it
Ну, то есть,
processes,
по
it
факту,
works,
что
and then
мы
it shuts off.
Пользовательские
So what do we have as a result?
прием
We have
запроса,
user interaction, we
функция
have request
и какой-то
acceptance,
storage. Ну,
then
storage,
the
опять же,
function,
тоже
and some kind of
есть
storage.
serverless компоненты. Не удивляйтесь,
There are
object
serverless
storage тоже
components,
является
and
serverless
object
решением.
storage is
Вы
also a
ведь тоже
serverless
не
solution.
обладаете. Ну, это
Obviously, you do not
вы там тоже не
have
обладаете
this
сервером, вы не
solution.
обладаете к
You
нему
don't
доступом,
have
вы тоже
server,
платите за объем используемых
you pay
услуг, он тоже
for
масштабируется. Ну, то есть по
the
факту это
access
тоже
to, you pay for the volume of functions. Basically, that's also a serverless solution. Now let's move on.
Но это решение само по себе, как только вы начали
This solution,
делать,
when you just started
только вы
with the
научились
solution,
писать первую функцию, и
once
я
you
наблюдал
learn
это
how to write
многократно
this
в
first
комьюнити,
function, and
которое
I've
я
seen this
строил
multiple
несколько лет,
times in the community I was working in and building for many years, a programmer that created the first function that worked with the incoming request, and it happened, and they send the data to database. It provokes it to work with decoupling.
Писать свою систему с минимальным
Create your own
размером
system
функций.
with the minimum
Маленький, быстрый, здесь,
size of a
здесь.
function.
Огромное
Very
количество
small,
функций
very
сразу у
fast
человека
functions,
появляется.
a lot of different
И это
functions.
неплохо. С
And
одной стороны,
I would
очень
say
круто,
it's not
потому
bad.
что
On the one hand, it's
с
pretty
точки
good
зрения event-driven архитектуры,
because
у него
in terms of
каждое событие
event-driven
превращается в
architecture,
систему, это образно,
each
маленькая
event
функция,
which happens in the
функция
system
минимальная по
becomes a small
размеру,
function,
значит, соответственно, она будет
very
загружаться
minimally
быстро.
possible function. It
Оно
means it
быстро
will
будет
load very
обрабатывать, потому что
fast,
обрабатывает
it
только
will be
один
processed
кейс.
very fast because
А
it
значит,
handles
соответственно,
only
будет
one
стоить очень
case,
дешево.
and it will be very
Опа.
cost-effective. It will be very cheap.
Собственно говоря, вроде бы все хорошо.
So
Ну,
it
как
looks
бы
and sounds great,
свойства
right?
подходят, и мы вроде как двигаемся в правильном
Properties
направлении.
work and we move
Но
towards the right direction. Yet,
если посмотреть на это с другой стороны, с точки
if we
зрения
take a
классической
different
архитектуры,
perspective
и
from
мне
the
очень нравится
classical architecture,
определение от
and I really like this
что вы на
definition
самом деле
by
управляете
Gregor
своей
Hope
инфраструктурой или
that
проектом
you
только в том
control
случае,
your
если вы на самом
infrastructure and
деле
project only
управляете его API.
if you
И в
control
целом
its
endpoint
API
вы контролируете.
and you control the
И,
endpoints.
кстати, рекомендую его книгу.
And by the way, I
Она
recommend
очень
his book,
неплохая, Enterprise.
Enterprise Integration Patterns, Design, Building,
Очень
and
хорошая,
Deploying
она много
Messaging
объясняет
Solutions
о том,
by
как
Gregor
строить
Hope
распределенные системы.
and Bobby
Кстати,
Wolf.
был вчера
It
совершенно
talks
замечательный,
about
когда я
the
был здесь ведущим на сцене, был замечательный доклад. Я
distributed
рекомендую вам
systems.
посмотреть, если
And
вы не видели.
yesterday, there was a great
Запись
presentation. I
на
highly
YouTube
suggest
есть,
you watch it.
как раз по
And
созданию
you can watch it
распределенных
online
систем.
exactly
Доклад был
on
от
the
Фила.
distributed
Супер доклад, отличный.
systems.
Если
It was by
вы
Phil.
можете быть с ним не согласны,
A very good presentation. You might disagree.
но рекомендую. Итак,
Still, it was a very good
дальше,
presentation.
давайте двинемся дальше.
Now, let's move on.
Вроде бы, если посмотреть
Seems
на это
like
определение,
if we take a look
вы
at
же
this
в serverless не
definition,
контролируете сервер.
you don't control server
Вы не
in
контролируете, как
serverless.
он будет запущен.
You don't control how it
Вы
will
не
be launched.
контролируете
You
в
do not
целом
control
среду, в которой исполнение
the
происходит. Вы
environment
написали
where
вот эти
it will be
20 строк
run.
кода,
You
и
just create
какую-то
20 lines of a
аннотацию, ну, в
code
смысле, права
and some
раздали,
kind of
чтобы оно там
annotation. You
все
just give the right so that it will be run in the cloud.
И это правда.
And it's true.
Проблема, которая
The
возникает, с
problem
которой сталкиваются
that
все разработчики,
arises
начинающие,
here
которые приходят в
for all the junior
serverless, это
developers
холодный
who
старт.
start
Что это
working
такое?
with
Сейчас объясню.
serverless
Смотрите, вы написали
is
функцию.
code start. So what is code
Например, вы
start?
написали ее большую.
You write a function.
100, 200,
Suppose it's a big
300
function,
строк.
100, 500 lines.
Вот,
Well,
но тем не менее,
it's a very
большая,
bad function. It's a
сложная,
very big
еще каких-то
function.
библиотек туда подключили, она
Complex
стала
one,
огромная,
lots of different libraries. It became
и вы разместили ее у провайдера.
well, and you develop it on the provider side,
Это
maybe in
значит,
Yandex
что
Cloud.
этот кусок кода, он
And that means
зашифрованный, он
that
лежит
this
где-то на
part of the
платформе, где-то
code
на storage.
is on a
Когда
zip
приходит
archive.
пользовательский запрос,
It
который
is
должен
stored
обрабатываться
somewhere in
вот
the
этой
storage.
функцией,
And when
значит,
there is a
эту
user
функцию нужно,
request,
этот файлик надо
then
перетащить
this file has to be
к кластеру,
moved
где запущен будет
to the
эта самая
cluster
виртуальная
where it will
машина.
be run, where the virtual machine will be run. It has to
И
be
вот
unpacked and
время
run.
холодного старта —
And
это
the time
время
of
от
the cold
момента,
start
когда
is the
пришел
time
пользовательский запрос.
from the moment
Кластер
when a
не
user
вашей
request
функции
arrived.
рядом, она на
The
storage
cluster
лежит,
does
и
not
время,
have
пока
your
вот
function.
будет создана вот эта виртуальная машина, куда
And
запрос
then
придет.
it's
И
the
вот
time
момент,
between
когда
when the
начнется
request
обрабатываться,
arrives
вот это время холодного
and
старта.
when it starts to be processed. So this is
И
the time
понятно,
of
что
cold
все
start.
платформы с этим борются.
And all
Ну,
the
что
platforms
можно
try to
сделать?
fight this
Можно
time, try
сделать
to decrease
вроде
it.
бы поменьше саму функцию,
Well,
ну, чтобы
what
она
can you
легче
do?
летала.
You can
Можно там
decrease
прогревать
the
эту
function
функцию,
in
то есть, чтобы
size.
вот
You
файлик
can
находился
maybe
поближе к
warm
кластеру,
it
то
up
есть, чтобы он
a
где-то
little
в
bit so
оперативном
that
кэше
the file will be
находился.
closer
Это разные
to
есть способы, мы потом
the
можем
cluster.
отдельно
Maybe it will
обсудить,
be in
какие
cache
есть варианты
memory
с этим бороться.
before it's
Но
run.
в целом,
But in general,
надо сказать, что холодный старт,
one must say
он
that cold start
предполагает, что вы пишете маленькие, короткие
supposes that you have small, short
они должны
functions.
быть
Point number one.
легковесные.
They have to be
Чем она
lightweight.
легче, тем лучше.
The lighter, the better.
Если у нас это что-то сложное, с большим количеством библиотек,
We are working
лучше
with
давайте упакуем это все
something big,
в
something
контейнеры.
with great
Контейнеры
volume.
для
It's
этого
better to
лучше
work with
предназначены.
containers. Containers are a better
И,
solution for a bigger
соответственно, дальше
function.
интересная история.
Next,
Нужно осознанно использовать быстрые рантаймы. Что это
you
такое?
have to be very
Ваша функция запускается, ну, она же написана на
careful
каком-то
with
языке.
runtime.
На питоне.
So
кстати,
you
пишется на
have a
Java.
function. By the way, who uses Java?
Немного.
Not many, not too many.
Вот.
Great.
Значит, мой любимый язык программирования. Ну так вот,
That's my favorite programming language, by the way. Yes, it's complicated, probably pretty big one, lots of different libraries, and maybe this is not very good for a function, but it works very well in a container. You put everything in the container, it is isolated. But what about Python? You could have different versions of Python. You could have Node.js, different versions, and this is a script. It's very lightweight, it's very small, it's very easy to run, and it is suited for this initial processing by the user, some kind of system. And this is what we thought about. This happened a few years ago when all the providers decided, well, it would be great if we could run the code really, really fast, if we know that this code can be run. And that's why they started to have these quick run times. There were versions of different interpreters, like the latest Python version or latest Node.js version, and they decided to create a special float of virtual machines, which are already, you just need to input data, that's all. Once they started to experiment with this kind of solution, it turned out that compared to the usual runtimes, for example, in Yandex Cloud, we had runtime 3.7, but in 3.9, we had a quick runtime. The difference is very big. 2.3 milliseconds, but 300 milliseconds for cold start. So the difference basically 100 times. When you have quick runtime, you already have prepared virtual machine, and we wait for you to come, and we will just upload your code. Clearly, we recommend the volume to be very small, lightweight scripts, and by doing so, we will get very good results. If the whole application is built on a function, and instead of big, complex functions with lots of different libraries, and you create instead small, very light functions, then during each run of the function, you will get those milliseconds back, hundreds and hundreds of milliseconds back during each of the run. People still forget that you have to use quick run times and create this kind of code. This is an error many people face. Okay, so it seems event-driven architecture, that it means that you have asynchronous processing, and it's supposed to be like this, but unfortunately, not everybody understands how it works. And when we are working with a simple single code, it's a monolith code, but we are using these kind of services. For example, we are using Mail, and just recently we had a preview of Postbox to process technical, and Alexander Filevsky will speak about how to analyze and process this kind of events during his webinar in the serverless approach from the point of view of the service, and I highly recommend watching and listening to his presentation. So the problem here for developers who create serverless solutions, and previously they had not this kind of experience, is that they have synchronous or maybe simultaneous waiting when they want to create this kind of function, and those functions have to wait at the same time. In terms of architecture, it doesn't really work, it creates a lot of different problems, and in this sense, it's easier, it's clear that there should be some changes in this architecture, and we recommend these kind of developers who just start working with this serverless architecture to add. And by the way, just Phil yesterday said that if we have a bigger message, it's better not to process it once again. It's better to split it into two parts. Well, I will paraphrase Phil, but basically what we do, we accept the request and we say, yes, we received your message. And the second message is, yes, we processed your message. And we do the same in the serverless solutions. The first request from the user, from the browser, maybe from Telegram, we have a message from Telegram, and we can say, I've received your message, thank you very much. And now we start processing. Then the function checked the message, it checked it means, yes, this is a legal, correct message. We put it for processing query, and we sent to the user, okay, we received your message 200 milliseconds. Now we work with the internal processing of the function. It goes to this internal microquery. Now it's very simple. We have many simple, small functions. And this applies to serverless solutions. And you pay only for the resources used. And I think that's a great solution. So what do we have as a result? We pre-install or define the dependencies between these elements. We analyze what kind of pieces could be processed, and we use queries just to split this vicious circle and split it into two different parts. And this is what's called asynchronous point-to-point model, or point-to-point model, a pattern where we have the incoming group with different sources. It analyzes the request from a user. Now we have the query, and then we have the developers who process it. By doing so, we are able to allow our system to be faster. Why is it important? Because we pay for time.
So we pay for the use of the time. This function runs if it runs fast. If it does not wait, we don't pay for this time. That's very important. So moving on, isolation and independent components. In ETL systems, such things do present. As soon as you have divided the system, each component may run on its own. It seems like you can test it. You can test it. The components are independent. It's great. But that minimal interaction with other components creates this wrong feeling when the developer writes the code. And when I write the code, sometimes I feel like I can locally test it on my machine. But when you make your system in the cloud, it's not a computer that you use there. It's a fully fledged system. You cannot really test it. Does it really work or it does not? Unless you create a virtual twin of your solution. And the serverless approach does it in a very simple way, because the classic approach requires a lot from you, a lot of resources, a lot of hardware and deployment. But the serverless solution allows you to create a fully fledged serverless copy of your app in a file which will create exactly the same resources you have and exactly the same number, and you'll be paying just only for the resources utilized. If there is no request, the system does not demand any money from you. So this problem of a quick launch disappears. And on the other hand, the amount of money required to run a test bench. People say, yes, indeed, we can do it. And an important point here, that you deploy a fully fledged infrastructure for testing, and you do it quickly. The only thing remains is that to fulfill the system with some events, the user events, the events that may be generated, and you can do it in a limited way, in a simple way. Non-typical solution, which may replicate this completely. And yet an important thing, when testing and people forget about it, they test it in the same cloud, and very often they rename the functions and they rename the variables, and that's not supposed to be done. The cloud allows you to create standalone folders, and in the Yandex Cloud you can create a standalone cloud for testing. And ideally, I think, and it's an important thing, like you said, the functions are deployed and the same exact solution is deployed. And you detect a non-typical behavior just immediate.
Масштабируемость. Ну, вроде бы она заявлена в
Scalability.
самом изначальном
Well,
варианте.
initially it was announced it's a serverless,
И
scalable
с
solution, and the function is independent, and the EDA systems allow us to scale it up very easily, like all experts claim. And of course, it varies. When we think about it much more seriously, we are getting into a very interesting situation. As soon as we speak about scalability, as soon as we start speaking about serverless, and here I need to warn you, a very important point that is important to mention. The serverless solutions show you the top to bottom very flexible and fluctuating load. When you would like to create a test load and load it to the top, nothing good will happen from that, because you will be paying for each single call. And the constant load is best transferred into classic services. The long-living virtual machines, the images that you deploy, Kubernetes, etc., because you always have this constant load, and you don't have this fluctuating pattern of engaging with the user. It's not always happening, of course. So when I show this picture to you, it does look like this. If you have some classic solutions that are processed with the classic applications in the monolith, it doesn't really matter, because it processes the permanent load, the top load, and these random peaks that may be generated by the users every once in a while can be handled in the serverless solutions in a very adequate way, and you can change this very quickly, because as soon as you move from the project condition and you've taken something, a commercial solution that, like the user is establishing it, you need to select the functions from where the user load is changing and fluctuating, and the containers where there is top load. And so you clearly, consciously use the queues, and we stop wasting the money randomly. And it's a great story. Again, when we address Yandex GPT, if there is something related to flexibility in EDA systems, everything works great. The flexible systems allow you to add solutions, and the serverless solution actually provokes you to publish this. And it's a simple thing, but it creates some other problems. No cloud wants you as a user to waste money, to spend money just like this. So quota is the number of queries, requests that you can send to your serverless system as inbound ones, so that we run a number of functions simultaneously. It's not a big quota. It's automatically set for every single user. There are approximately 10 functions that you can run simultaneously. If they are short ones, you get the volume that you can process simultaneously. But there's an important thing. You need to understand that if there is a big load, if there are lots of users, you may run out of quotas. Even if it's a fluctuating load, you need to be prepared for that. For example, when you run an advertising campaign, it appears and people forget about it, and they connect the hotline of support saying that our app does not work, and you check the load and you see, okay, we expected that, you need to raise your quota. Okay, let's raise our quota. And people forget about quotas. And here you analyze the behavior of your clients. You just need to toy with quotas, and it will help you work quite actively. But again, if you raise the quotas, more users started appearing in the system, and we started processing that, we started putting it in queues. And there are workers, and they are initiated by triggers, and everyone forgets about the triggers, and each trigger also calls the function. And then what? You need to raise the quota, you need to increase the quotas, not only on the inbound queries, but also on those that will be generated by the enhanced load, because you have triggers, requests, and sometimes it's multiplied by 3, then by 1.8, depending on the architecture. So you just need to play with the quotas. So don't forget about this trigger loads. Inner events in the system are generate triggers, and don't forget about the queues. It's a non-typical behavior that should be minimized, and it can be minimized. And like I explained, I've seen your smiles here. You say, okay, seems like that, but maybe we didn't even notice that the load was growing. They didn't notice that because they forgot about alerts. When you create a pet project, when you create the first solution, they never think about a load in the cloud, that they need to monitor it. And then all of a sudden, oh, okay, what I'm going to do about it? But you need to set the limits right.
И вот этот вот разработчик, который
пишет alerts into the monitoring system. Он написал вот Python script that they created, or a Telegram bot, do not require any alerts or any monitoring. They say, what kind of quotas do you want from me? But it's true. Nobody expects the Spanish Inquisition, but the inquisitors just knock at your door. Because you are the real developers, and it's a cloud solution, so don't forget about it. So what helps us fight all these things? The discipline does, to a certain extent. And if we could select something very important here in my presentation, it's the book that I'm showing you on the slide. We all live in the cloud, and we will live in the cloud in the near future, and the clouds will not go anywhere. So we need to use the resources appropriately, and we need to understand how we use the resources. To understand that, we need to understand how we spend our resources. Any architecture we create spends money. The correct architecture is the one that spends less money. And I'm referring to the yesterday's presentation of Philip. This book describes your approach on how you can fully tune your solution about analyzing the current situation and understand how this works in terms of spending of your resources, setting the limits, setting the cost optimization. And to give it a try, you can write a Python script and try this out with the 50 strings of code. It's clear just to create this script. Obviously, it will lead to decoupling, especially when you write a lot of scripts. You must test your solution when you create it in the cloud. And if you would like to try and implement FinOps in your daily work, you need to do the following. A simple example. You take your solution, you process the images, for example, you work with QR codes, the numerous ones which we've seen here. You can do it just for a few hours in the evening. And you put it in the cloud, and you make a couple of requests just to test it that everything works well. And you will have a ship made in the cloud of these tiny bricks. So what are you supposed to do? You can create a trigger.
Первый, значит, соответственно, QR-код — это
And the first QR code is a simple story. You go there, you write the function, you check this GitHub example, and then it says how you can do this FinOps solution with the serverless function in Yandex Cloud. It's an example with virtual machines. You've launched a number of virtual machines, VMs, because you're you are obviously accustomed to use of the virtual machines. So how to make sure that you run out of the budget, and how do you evaluate it? You need to run it today, but you need to shut it down tomorrow and the day after tomorrow. And you spend 10% of your budget now, then 50% of your budget, and 100% of your budget step by step. And you can deactivate some of the functions, send some options, send some messages, I mean, and give a signal. Okay, we've spent 25% of our budget somewhere. Check this for us, please. So I do recommend this book for you to read. It just very conceptually describes how to use the serverless solutions in the cloud. It's a very important story because you're going to live with this. Serverless maybe do not touch you, but FinOps will definitely touch you. If you would like to try something out, please join our community of the serverless solutions developers. It's all about queues, it's all about creating solutions together. They're very nice guys, they work really well. So overall, if you would like to talk about some more communities, we actually have our Telegram channel. You can join. You can join. Our colleagues from Yandex Cloud have created the Inside Yandex Cloud channel. Please join this and fill out a form, join the community, and this is it. Success. And I'm done. Thank you very much. Thank you very much for your time here. So if you have any questions, I'd be happy to take them. Thank you very much for listening. Let's applaud Anton.
Мне кажется, мы все узнали о серверлess решениях, и, наверное,
seems like that we found out everything about serverless solutions, and after this presentation, every person or every second one here will run their test projects on serverless Yandex Cloud functions. I would like to remind you about the use of the QR code, which you can utilize to evaluate the presentation. Please use it. If you have the Telegram bot open, you can send your questions there. So our viewers are currently doing it, and I'll try to ask this question. I'm professionally deformed in terms of cybersec, which is a good thing. In your presentation, you never mentioned anything about security. What about that KMS servers that I mentioned? You knew that. So anyway, imagine me being paranoid about security, and I have my own VM. It runs exactly what it needs to be running. I have all of the DevSec comps there, and all of a sudden I move to the serverless solution. How can I be sure that all of the functions that I have on my server will not be compromised in the cloud in terms of compromising the file system, etc.? Could you elaborate on that? I think we should split your question into a few parts because it's a very complex question. How can you be certain about this serverless solution, which is in the cloud? In actual fact, you should trust to a certain audit conducted, and serverless solutions are regularly audited. And you can check the entire list of people, and it actually loads the team. Each audit actually loads the team, but there are some financial solutions, and there is very strict encapsulation requirement, access control, a lot of things that are tested. And the serious load at certain times, up to 30% of working time is spent on audit, on fixing some things which are taken in there as new ones. We're not stopping there, we complicate our lives, but you need to be sure. You need to be sure as a consumer. That's number one. Number two.
Немножко еще чуть-чуть попараноид, да, вот, например...
You can also be a little bit more paranoid. I speak about functions. Like I said, the functions are script 20, 50 lines of code, strings of code, and you send them to the cloud in an open form, people think somebody may steal my code. Okay, let's stop being paranoid. We are being a little bit paranoid. But anyway, imagine that we have an opportunity to package this code into an image. Into an image.
Чуть-чуть, немножечко, я
So
понимаю, чуть-чуть
the
оторвались.
the trust increases,
Не
of course.
100%, но уже чуть-чуть.
It's not
Во-первых,
100% success,
не
but
в
imagine
рантаймах,
this
да, про который
image.
я вот уделил какое-то внимание, да, в том числе.
It's not running
А запустить serverless контейнер.
runtime, but in a serverless container.
Другой сервис, но он построен по тем же
It's a
абсолютно
different service, but it utilizes the same principles like a function. You put a Docker image in there, and it's pulled in there, and there's cold start, but there are no fast runtimes.
Ну, то есть там есть подготовленные уже под парами стоящие виртуальные машины,
There's a virtual machine prepared, just waiting for this
но
image to
здесь как бы
use.
какая-то жертва небольшая, то есть как бы тут придется
Yes, it's
скоростью чуть-чуть пожертвовать.
it's some concession to be made here. You just need to concede some speed, of course, and
у тебя
a bit of a performance.
большое
But
приложение.
when you work with the data and you have a very branched solution, not just 10 scripts,
Работа с какими-то ключами, с
it's
базами
obvious
данных.
that you work with the keys, with databases, and you need to use the safety, security systems. You need to monitor the logs. You just need to connect the KMS so that you should not put your keys in the GitHub.
Ну, да-да-да. Вот.
Why not use
Использовать КМС. Прекрасно все шифруется. У меня, кстати, есть тоже на GitHub, если кому-то
and
надо.
on GitHub, if you really want it, there is an example
Ключи, шифрование.
of how to use the encryption keys.
Вот, ну и так, и из таких
So anyway,
вот, я не отвечаю полностью на твой вопрос.
I'm not answering completely to your question, but out of these tiny things, we just increase the trust to the serverless solution. You should not be just 100% sure, but I needed to polish this a little bit. We expect a presentation from you, the next conference, about more details.
Небольшой организационный момент. У нас следующий спикер задерживается на 5
The
минут.
next speaker actually will be here in 5 more minutes, so we have
Давайте
more
начнем.
time for questions. So let's start.
Спасибо за доклад. И вот здесь тебе сразу
Anton, thank you very much for this presentation.
говорится.
Andrei thanks
За
you.
презентацию.
He says thank you for your presentation. They actively use serverless functions by Yandex
Ну, вот
for
только у
about
них
2 years.
такой
But
вопрос. Зачем вы
that's the question they have. How come you overcomplicated the scaling up of the functions, the concept of scaling? Why couldn't you limit the number of simultaneously working ones? We would like to have 100 calls. And he
Мы понимаем, как работают лимиты.
clarifies. We understand how the instance and request limits work.
Ну, повторю, почему нельзя было
But again,
сделать
why
один
couldn't
общий
you
регулятор?
have one
Вопрос у Андрея.
common regulator?
На самом деле,
Could you answer
если
that?
прям совсем все отбросить, вот прям совсем все отбросить,
Well,
регулятор-то общий. Вот,
if we
на
take away the how,
по
we should
факту
say
лимит, он
that the regulator for
является один. И в этом как раз
functions
есть одна из
is
проблем,
just
когда мы
one,
говорим про
and the
триггеры.
limit is one.
Триггеры,
When I
они
spoke
тоже
about the
запускают
triggers,
функции, и по факту,
triggers
как бы у
also
вас
trigger the
работают триггеры,
functions.
а
It's the
запускаются
triggers that
функции.
work, but it's the functions that are launched.
Чтобы и было удобно, да?
But they would like just to have one
Тут
single
важно
flag
еще отметить,
and
что лимиты
one single
представляются
tick and
на
make it
количество,
convenient.
Функции, которые одновременно запущены в один момент
The
времени
functions
в одной,
that are
в
launched
одном
at a
из,
single moment in
в
time
одной из зон доступности.
in one of the
Поясню. Полноценное
accessibility
облако, оно
areas.
всегда
The
стоит
fully
на нескольких
fledged
ногах,
cloud
несколько,
is always
соответственно, дата-центров,
grounded at a few
у нас
legs
сейчас
and a
в
few
России
data
3
centers, of
больших
course,
в Yandex
that are
Cloud
separate.
дата-центра,
In
ну,
Yandex
4
Cloud,
по факту,
we
потому что
have
сейчас там переезд
4
осуществляется. Кто участвует,
data
кто в Yandex
centers.
Cloud находится, они
Those of you who are in the
периодически
Yandex Cloud, you always get this reminding.
Please
Please urgently move your virtual machines. And in every data center like that, we launch a certain amount
ну, вот этих вот виртуальных машин, да,
of the so-called virtual machines. They could be serverless containers, the functions, and the function called after being triggered. And the 10 is installed by the default here, here, and here. And now you see you're very experienced developers. So if you have a distributed system,
если вам нужно сделать
if you really need to have one common regulator with 30 functions, you just need to connect them and check and verify that there are 30. If we have 10 here, 10 here, and 10 there, I can switch and check them on the spot very quickly, in the twinkle of an eye. Architecture-wise, it will be a simple solution. It's purely a technical trade-off that you need to come to. So in terms of the development of the distributed system, it immediately creates another failure point, etc.
Ну, надеюсь, Андрей.
So it seems like it's not the option. But we can always fine-tune it and tune it up anytime you like.
На то, чтобы вот есть у меня
So
монолит.
there is a monolith, and I don't really want to think how it will be distributed. So I put this monolith to Yandex Cloud, and it cuts it into functions and inserts the functions, the triggers, and it's all distributed into 3 areas. Well, it's an interesting story, but if you pay us a few billion, we'll think about it. Well, I think about where to get the 30 billion. The next question comes from Sergey. He says that serverless looks great for serverless tasks. What if for the event processing you need to work with the heavy context? And how can you cache the data to be reused between the requests? They are great questions. This closes this problem because you obviously need some place to store the solutions. In any serverless solution, there are 2 concepts. Another one is compute, is computing the functions, the containers that are regularly uploaded. And the second story is a storage, something which we store. We store the files, and there are 2 components that we store immediately. We store the files and give them out. And we can transfer a file, to put it this way, a certain amount of data. And in the database, there are 2 components as well. There's a component of storage, which is constantly spent, the disk. And the second component is processing. The SQL, for example, we process it, and that's what we call compute, the second part. So we can move it from here to there. In terms of storage of the user request, for example, it's a big one.
В моем предыдущем ответе, мы должны разделять его на 2 части. Принять.
We need to split it by 2 parts. We accept it with a big amount of data. Immediately, this data is sent to the database or open storage, and we accept this data, claiming that. And we say, good luck, great.
Уже там есть
We will not lose
какая-то
it.
доступности, уже там в Object Storage оно в нескольких экземплярах уже хранится. Все прекрасно.
We can store it in a few.
Вот. И, соответственно, дальше мы занимаемся вот тем сложным контекстом. Например, мы можем по кусочкам эту задачу
And then we can
ну, например,
process this task by pieces. We have a complex file,
мы взяли видео,
like a video, for example, a video file. We upload it to an open storage, and we need to cut out a video out of it. And we first upload it to open storage, and then we run the function, which will cut out 2 minutes. So we need to separate the request by accepting and launching. And here is an example of the film, at the GitHub, the big files. And there is another example, you can use them. It's the heavyweight context.
Чтобы переиспользовать между
So in order to reuse this, what are you supposed to do? For caching, there are two types of queues. We have the small queue, message queue that I showed you, the inbound requests that we take, and there are Yandex data streams that are very much alike.
На самом деле там интерфейс Kinesis, Amazon.
And there is an Amazon interface that you can reuse it. So everything which is short, it's put in the message queue, first in, first out, and everything which is complex is put in the Yandex data streams.
Мы все прекрасно понимаем, что там внутри. Ну, точнее, это наша самостоятельная разработка, просто интерфейс.
Obviously, we do understand that this is our proprietary development, and you work with full-fledged query. It works with all the storage guarantees, and it actually uses what you are paying for.